Now for part 13. In this video, ladies and gentlemen, talking about the domain and codomain swap. Intuitively, this is what's going on as a natural consequence of the input-output reversal property. We'll do a proof and example. To clarify, a domain and codomain are part of a relation, which is a set of ordered pairs where the first element is from the domain and the second is from the codomain. A mapping is a specific type of relation that must meet two conditions. Every input must be mapped to an output. There are no unused domain elements, and every element in the domain is mapped to exactly one element in the codomain. The white box is a mapping. The relation, formed by swapping the domain and codomain, more precisely, swapping the elements in all ordered pairs, is called the inverse relation. Like the proof we just did, we'll use the idea of a relation again for the proof very shortly. First, though, we'll refer to four definitions listed as the white box. For a function to be surjective, its range must equal its codomain. For a function to be injective, each element in the range corresponds to exactly one element in the domain. We've discussed those topics, so we're good to go. The last definition, second blue bullet. The definition of an inverse function says, if f of x equals y for x an element of capital X and y an element of capital Y, then f inverse of y equals x must be true for the same. Third blue bullet. In a similar way to define a surjective function, we can narrow what we just said as the following definition. If an original relation R, which consists of a set of ordered pairs, x and y, then the inverse relation R inverse is the set of all ordered pairs y and x, which says the domain of R inverse is the codomain of R, and the codomain of R inverse is the domain of R. First orange bullet. The inputs of the inverse function f inverse are the values y that come from the set capital Y. Given what we just said, therefore, the domain of f inverse is the set y. This is exactly the codomain and range of the original function f. Together they describe the domain reversal. Now consider the second pair of orange bullets. The outputs of the inverse function f inverse are the values x that come from the set capital X. Therefore, the codomain and range of f inverse is the set x. This is exactly the domain of the original function f. Together, they describe the codomain reversal. Last orange bullet. Essentially, the inverse function f inverse simply reverses the mapping of the ordered pairs x and y, which necessitates the swapping of the entire domain and codomain. We are done. Nice. Let's do an example. Use the mapping in the yellow box and the specific rule blue box. We're assuming the blue box is injective. Because we believe a proof is straightforward, we can use the technique of contrapositive from previous proofs. So in order to save time and energy, we'll skip it. However, we just did a proof that f of c is surjective. That's what we needed to do a domain and codomain swap example. First orange bullet. To find the inverse function, replace f of c with f. Second bullet. Swap the variables f and c to get c equals 9 over 5f plus 32. In case you don't know, c is degrees in Celsius, f is degrees in Fahrenheit. Second column, ladies and gentlemen. First bullet. Solve for f. Last bullet. We can rewrite it as for a function f inverse of c equals 5 over 9 times c minus 32. Consequently, f of c and f inverse of c is consistent with the third blue bullet. See that? That being said, we can confidently say the domain of f inverse For all real numbers, capital R, any Fahrenheit temperature can be the input, which is the original function's codomain. Also, the codomain and range of f inverse for all real numbers R, any Celsius temperature can be the output, which is the original function's domain. Thus, the domain and codomain swap characteristic is clearly demonstrated. The domain of f of capital R for real numbers became the codomain and range of f inverse, and the codomain and range of f of R for real numbers became the domain of f inverse.